Okay, let's talk about the octet rule. Now, the octet rule is going to apply especially to covalent bonds, and we see that it says representative elements can fill their outer energy levels by sharing electrons in covalent bonds. So what the octet rule means is that a compound tends to form so that each atom has an octet, or has 8 of the electrons in its highest energy level by gaining, losing, or sharing electrons. Okay, we specifically see it a lot in covalent bonding when we do the Lewis structure. We always talk about if 8 is great. So if it has 8, we know that it's happy. Make sure that we know that. Realize that everything wants to follow the octet rule. Everything wants to have 8 valence electrons. That's just when it's the happiest. Now, the duet rule, and there are some exceptions. The first is the duet rule that we see down here. It applies to hydrogen and helium. Those guys are happy with only 2 electrons. They don't need 8 electrons. And normally what we see is that when hydrogen, once it makes a bond, it has 2, it's happy, it's done. Some other exceptions that we have to the octet rule, we can have less than 8. Boron's one of those guys. That you can have 6 in the outer energy level if it has to, and then we see that more than 8, anything in the 3rd period or heavier, because remember that they have to have an empty d orbital to have the ability to have more than 8. They need that d block so they can force them in there, and we see that those guys are going to be sulfur, phosphorus, iodine, and you can see some example. This is sulfur hexafluoride, and this is phosphorus pentachloride, and we see that this one has 12 electrons around it, 2, 4, 6, 8, 10, 12, and this one, phosphorus, has 10, because we have 2, 4, 6, 8, 10. So those are some exceptions to it. Just make sure that we understand what the octet rule is, that everything wants to have 8. There are some exceptions, but remember, octet rule, just want to have 8. 8 is great.